everyone. Today we have our another new episode, and we will discuss on AI in climate change. We have our world famous speaker, Mr. David. Thank you for joining today's sessions. And for these discussions, we actually have some sort of information and research on that particular area, and we do focus on some issues about AI in climate change. We have monitoring and data analysis issue, and we can use imagery and remote sensing. We can go for climate modeling. We can go for mitigations, energy optimization, renewable energy management, adaptation measure, disaster response, and agricultures. We have to go for policy and decision making, policy simulations, and carbon footprint. For example of AI actions, we know that Google AI for weather forecasting is important, IBM Green Horizon is important, climate trace is important, challenge and considerations, we have data quality and accessibility, energy consumption of AI, equity and inclusions is AI important. And for future directions, maybe we can focus on cross-disciplinary collaboration, advanced AI technology, and global cooperations. So we have our famous speakers for that particular discussions. My first question for him: how can AI improve the accuracy and reliability of climate model and prediction? It's mean investigating the role of AI in enhancing climate simulation and weather forecasting. What do you think about that?
Well, great, and thanks for inviting me. Really, this is an impromptu call. With my brother here, just gave me a call kind of out of the blue, so I have no way of preparing like a script or anything. So we're going to kind of try to dive into this subject, which is really a very dynamic and very complex scenario when we start talking about the world of artificial intelligence. And the reason why I say that is because the work that I'm doing, and by the way, my name is David Ferdinand. I'm here in Brazil on Evolution Island off the coast of Sao Paulo, Brazil. And people call me David the Indian. I have my own podcast called The Power of Islands. And for the last 25 years, I've been traveling throughout all of the Americas and all of the Caribbean and basically learning and acquiring lessons learned, intellectual property, and also building networks here in the Americas specifically. I haven't been into Asia or the European or Africa or any of those other markets, really just focusing the work that I do or have really just kind of grown into. When we start talking about AI, my degree is in business, an MBA degree from the University of Rhode Island, and my focus has been on international business, conflict resolution, finance, and these things that really, for me has been really a very interesting development, career development. And like this show, the World Talent Economy Forum, for me, I've kind of morphosized into it in the field of AI. It's pretty interesting story. I don't want to get into all of that. I want to try to stay quite as technical as we can, and really focus on the issue of climate change, specifically related to AI and computer information systems. And in order to do that, I believe we need to today talk about a new development just happened, I believe about a year or so ago, with MIT Media Labs. MIT Media Labs in Cambridge. I know my brother here is in Stanford in the United States right now, but on the other side of the country in Massachusetts at MIT Media Labs, they came out with a press release, I believe about a year or so ago, with Google AI Clouds, and disclosed this technology they discovered called time crystals. Have you heard of time crystals?
No, we can learn from this session. That's why we are organizing this session.
Hey, great! And for all the students and all of the people following you in this stream, in this live stream, the time crystals, and mind you, I'm not like an official scientist. I call myself right now a quantum physicist and a quantum inventor. but you really don't go to school for that, because the information like time crystals are just discovered. I mean, there's really nobody that's a time crystal expert. And I mentioned time crystals because time crystals have three fundamental functions or results of this technology, three areas. The first one, and let me first, before I mention the three areas, time crystals are a water. It uses even the ocean water, any water can be separated into, in separating hydrogen from the oxygen. And what the MIT and Google realized, and through research and development discovered, is that when they make the separation, what they can do is amplify the hydrogen molecules, not 1, 2, or 3 times. We're talking about trillions of amplifications. And then when that happens, the hydrogen actually creates the crystallization. And through that crystallization, what they found is that they can achieve 3 very, very important things that affect everything, not just AI, but literally our whole world that we live in. And I'll say that because the first area that time crystals produce is an unlimited, abundant energy supply. We're not talking about free energy. There's really no free anything. Even this time that we're sharing together right now, I'm not.
Thank you. Thank you. We have to go for some focused discussion. So thank you. We have to go for next questions for you.
Okay.
What can AI improve accuracy and reliability of the climate model and predictions?
Okay. What I'm trying to get to, and bear
just
with
me. Give me just 30 seconds. And what are the potential risks and benefit of using AI in climate change mitigation and adaptation? Yeah, that is my focus discussion right now.
Yeah. There's a huge amount of benefit, obviously, in using AI systems. Like I said, the work that I do is with intelligence. So it's the artificial and the natural that make up what we call total intelligence. And so when you start looking at modeling and mitigation and all sorts of impact, what it really comes down to is the combination of the artificial intelligence with the natural intelligence in the world that we live in. So, I get back to time crystals because time crystals do 3 things. One is energy. The second is data bandwidth. And this is where the AI modeling and any modeling comes in, because what the problem is with traditional silicone chips, which, by the way, Taiwan is actually like a monopoly where these silicone are produced, and the rest of the world, in India and in Africa and wherever, are not producing these components for quantum computers and quantum processors. So the time crystals energy, the bandwidth is unlimited. And the third thing is that the data speed is unlimited data speed. MIT and Google has not measured the data speed. Why are these things important related to modeling? Is because what we really want to try to achieve is a real-time modeling. And that means we need to be in the present moment. And in the present moment, we need to be able to gather all of the data, which is unbelievable. A standard quantum computer, any quantum computer, does not do that with a silicone-based processing chip. It doesn't accomplish that. But what I'm saying right now with the modeling that we're working on here on Evolution Island, we do have a quantum research lab and station. We do have an advanced science project that's actually looking into how to integrate these time crystals into these modeling systems for specifically a very controlled scientific area where this island, Evolution Island, there's 7 islands. We're right off the coast, only about a mile off the coast. And there's only one road that goes along the mountains that come down into the ocean. And so our area is a controlled scientific area that allows us to really measure with accuracy and prediction models and tracking models and weathering models and what have you. So the project is called BioFreeDome, and that's DOME. And it's actually has a localized satellite, which is called a Spooky. It's called Spooky. And this satellite is like a box. It's the size of a shoebox. It's a small satellite. In the National University in Singapore, Dr. Alexander Ling is the one that has discovered what's called quantum keying, in a process where he's using these satellites in out of orbit, and actually through the process of these time crystals can relay that data transmission in real time. And keep in mind, out of orbit is a long distance, so any type of transmission takes time. But with these time crystals, the speed of these time crystals, like I say, is unlimited.
Thank you.
Speed. And so go ahead, go ahead. Ask
my next question for you: how can we ensure that AI-driven climate solutions are accessible and benefit to all communities, including those most vulnerable to climate change?
Well, what we do here specifically is that I don't patent this technology, and the information that I just shared with you and the public and anyone listening to this, hopefully everyone starts to go on their own and do their own research about the area of time crystals, because like I said, energy, the bandwidth and the speed of data is what AI modeling, mitigation and prediction modeling in real time measurements is all about. What's interesting is that we actually believe that we can alter the climate. Now, that's crazy. When, for example, I'm from the United States, I spent a lot of time in Florida. And so when we have these storm systems, hurricane systems that form way out in the ocean, what we believe is that we can actually utilize these satellites, even from out of orbit, and be able to break up and actually disperse and almost use like a vacuum cleaner in either redirect or totally dismantle a condition like a hurricane or tornado. Tornadoes are tough because they develop so rapidly, but hurricanes are easy because normally you get weeks of time. There's all sorts of weather prediction, Doppler radar, and all sorts of technology that uses regular computer chips and whatever. So the sophistication of our science is, we're already there. But what I'm talking about is advanced science. What these time crystals are technically is extraterrestrial intelligence. This is beyond the human capacity in laboratories, even at Stanford University and in Silicon Valley and in SpaceX and everything. And go ahead, ask another question.
My next question: what steps can be taken to reduce the carbon footprint associated with training and deploying AI model?
That's a very interesting question. And what I would say, the issue with carbon footprint relates directly to our consumption. And so we learned, for example, with COVID, very specifically, it was unfortunate we were locked down and all of the issues related to, I don't want to say deep state control or what have you, but really the benefit or the byproduct result of all of that was that our Earth, the ozone layer and everything started to repair itself. So basically our carbon footprint is a direct reflection of our consumption it's greed in our desire to have more and more and more and just be an unsatisfied appetite for more. So the carbon footprint related to AI modeling and any prediction, and I'm not trying to say this to really disrupt any markets or any industry or whatever, because I really believe instead of consuming more, what we are arriving at is consuming, it's not quantity, it's quality. And that's what the AI modeling, prediction models, these time crystals and whatever really produces, a real-time result. And quality comes from now. The moment of now in real time is where the quality always is. So if we are thinking about the future, which is what predicting models is really about, that's not accurate. You cannot accurately predict the future that way. in the moment of now, if we stay in the moment of now, then we can act accordingly and not knee-jerk reactions to issues related to carbon emissions and all sorts of things, even like electric cars with Elon Musk. That's so ridiculous. That technology is not a optimization of transportation, alternative transportation mode. It's not. These cars that are being produced are producing hazardous waste materials, and the batteries alone in these electric cars are so heavy that they had to re-engineer the tires on these cars. The tires have to be an extra durable plastic, and these cars are heavy. So when you take an electric car and you drive it on the road, it tears up the asphalt. And so our infrastructure is not prepared for a mass release of these electronic cars, quite honestly. And with AI, with systems, and with these technologies that I'm explaining, these advanced innovative technologies, we are tapping into right now through these time crystals into what's called the vacuum. So everything in life has two sides. One side is gravity, which is what we live in. And that's why like an electric car kind of makes sense, because it's not levitated. The other side of gravity is vacuum, what's called vacuum discrepancy. And even Einstein and even Harris, the person with Renaissance Academy, I think it was Harisham Harriman. I'm sorry if I missed.
Yeah.
Anyways, he's you know who I'm talking about. Everybody in the world scientifically is really trying to find out definitively and absolutely what is this the vacuum discrepancy, because in nature everything has two sides. So if you have gravity on one side, what's on the other side? The answer is vacuum. And with vacuum, then you have levitation abilities, so that you don't have to have a car with tires. You can still produce with like
Thank you. My next question for you. Yeah.
Go ahead.
Yeah.
Go ahead.
Yeah. So my next question for you: how can policymakers and scientists collaborate to effectively integrate AI into global climate change initiative? And what's your closing remarks for today?
Okay. Well, it all comes down to cooperation, solidarity, and unity. So you can kind of separate out the two, like policymakers and scientists, but they're really one. You know, that's really what it comes down to, is our ability to have these open communication channels without having the censorship and without having the special interest groups. I have mentioned MIT Media Lab in this technology with time crystals, for example. This is inside information. You're not going to go online and find out about these types of technologies, because MIT and Stanford, and even a project that we talked to before we came on, my brother and I talked to about a project that he's working on and why he's in the United States, is not a top secret project, but they have non-disclosure agreements. He's excited. I already know, and I can sense it with the energy that he's on. You guys are working, your team or whatever, have a very important project. And anyways, MIT, getting back to MIT, some of the 200 most powerful companies in the world control the innovation that comes out of MIT Media Lab and all of the labs and think tanks and incubators around the world. And that is really the issue for our society to advance and our human consciousness to evolve to a point of total intelligence, where everyone has common sense, not just the scientists and policymakers. We're talking about the mass population being empowered and enriched with the not only encouragement, but motivation to go into the fields of STEM, which is science, technology, engineering, and mathematics. We're talking about areas that typically were for very specialized individuals that could go to Harvard and Yale, Princeton and Stanford and all of these other places. But now with these time crystals and with our library information systems, I can go to Stanford. I can take the course and I can get that information and I can download. Anyone can, because now we have open systems.
Thank you. Thank you.
Really
just in 1 minute, you have to go for closing remarks. Thank you.
Okay. Well, in closing, I want to thank you, Sharif, for offering me to get on this and jump on this call with you. It's very exciting. I'm sorry so much. I know that you spoke about a tragic event in your life where people died and what have you. And like I said, with policy and with scientists, let's all come together, not just policy scientists, everybody, attorneys, the judicial, legislation, the political election, everybody. Let's come in unity. In the center is where the quality is. On extremes, in the extremes, on the left, extreme left or right, we have problems. That's where chaos exists, and that's where people are greedy and want to monopolize something like time crystal technology for these 200 companies, and do not want to penetrate or offer this to the whole world. Because a place like India and Africa, you can produce everywhere. That we have ocean all over the world. We have water, and inside of all water at the center is the plasma state. And that's where these time crystals come from. So it's very exciting, very exciting. We are on the edge right now of evolving human consciousness, and shows like this for the World Talent Economic Forum to really educate, really motivate, especially younger people, but also older people. You can be retired. There's no age limit when we start talking about these things. Thank you so much. I could talk forever.
Thank you. Thank you. Thank you. I request all of our audience, please share our content, and I request to you, share our content with your community. Thank you. Bye-bye and take care.
Bye-bye.